Okay, question number 10. A mixture of gases contains 0.31 of CH4, 0.25 mole of C2H6 and 0.29 mole of C3H8. So the total pressure is 1.5 atm. Calculate the partial pressure for C2H6. Okay. So when you want to calculate the partial pressure, you actually need to calculate the mole fraction before you can calculate the partial pressure. So what is a mole fraction? So the mole fraction is actually the number of mole of the gas that you want to calculate divided by the total number of mole. So now you are going to calculate the partial pressure for C2H6 and the number of mole is 0.25. So divided by the whole number of mole, which is 0.31 plus 0.25 plus 0.29, you should get your mole fraction equivalent to 0.2941. So when you want to calculate the partial pressure, is equivalent to mole fraction times the total pressure. So total pressure is given in the question. Here the total pressure is 1.5 atm, therefore 0.2941 times 1.5 atm, so you will get 0.4411 atm as your partial pressure. Moving on to question number 11. The temperature of 2.5 liter of gas initially at STP is raised to 250 degrees Celsius at constant volume. Calculate the final pressure of the gas. So in this kind of question, the most important part is this one, constant volume. So you don't even have to bother about this 2.5 liter. So you have two part, initial and also final. So initially it is at STP, right? So then the temperature is being raised to 250 degrees Celsius. Okay. So initial temperature, because it is at STP, the temperature should be at 273 Kelvin and the pressure should be 1 atm. So therefore this one, it is not in the unit that we want. We should change it to Kelvin. So 250 plus 273, so you will get 523 Kelvin. Okay, now the question asks you to calculate the final pressure. So P equivalent to what you want to find. So it's hard for you to remember all of the formula for gas law. So what I encourage you to do is you just have to remember one, which is the ideal gas law, PV equivalent to nRT. So now we are only looking at T and P. So we are only looking at P and T. So the rest of the thing you can just omit. So when you want to bring the T over here, so it became P1 over T1 equivalent to P2 over T2. So once you get this formula, you can actually just plug in all the values that you have. So you have P1 over T1 equivalent to P2 over T2. So your P1 is 1 atm divided by 273 equivalent to P2, the value that you want to calculate, over 523 Kelvin. So therefore you will get your P2 equivalent to 1.9157 atm. Question number 12. The pH of a 0.10 molar solution of formic acid is altered to reach 2.39. Determine the Ka of the acid. So, the hint here is the pH is given to you. So, pH is equivalent to 2.39. So, from this pH, you can actually get the concentration of H+. pH is equivalent to negative log H+. Therefore, H+ is equivalent to 10 to the power of your pH 2.39. So you will get your H+ equivalent to 4.0738 times 10 to the power of negative 3. Okay, next we are looking at here Ka. You were asked to calculate the Ka. So when you want to calculate the Ka, the only thing you can do is that you need to make the ice diagram. So in order for you to make the ice diagram, you have to do HCOOH will dissociate into H plus HCOO minus. Okay, then you are going to do the ice diagram, ICE. So if you look closely at the question, it states here that the pH of a 0.10 molar solution is such. So it means that the initial concentration here is actually 0.10. So initially, there's no dissociation happen, so 0 and 0. Since this is a weak acid, so it does not dissociate completely. So here is negative X, positive X, and positive X. At equilibrium, you will get 0.10 minus X, X, and X. So what we can see here is that you already have the H plus at equilibrium, which is the value of X. Here before, we have calculated the concentration of H plus. Therefore, X is equivalent to concentration of H plus. So, X equivalent to 4.0738 times 10 to the power of negative 3. Since the question asks you to calculate the value of Ka, so Ka is equivalent to X times X divided by 0.10 minus X, which you get from your ice table over here. Whatever in the product divided by whatever in the reactant. So, since you already know the value of X, so just plug in 4.0738 times 10 to the power of negative 3 square divided by 0.10 minus 4.0738 times 10 to the power of negative 3. So supposedly, you should get 1.7300 times 10 to the power of negative 4.